Hello everyone, I am Raj and let's look at today's question on Leetcode 2904 shortest and lexicographically smallest beautiful string. You are given a binary string s and a positive integer k. A substring s is beautiful if the number of ones in it are exactly k. Let len be the length of the small shortest beautiful substring. Return the lexicographically smallest beautiful substring of s with length equals to length. If S doesn't contain a beautiful substring, return an empty string. A string A is lexicographically larger than string B if the first position where A and B differ. A has a character strictly larger than the corresponding character in B. And here example is being given in question. So we can see that in test cases they have been shown that what can be the answers. And let's see about constraints are saying that s at max can go up to 100 and minimum 1, and k can be up till s dot length means near means up till 100 only. So let's think how we can solve this question. As in question it is being told that the length of the string will always be less than equals to 100. So from this we can think that as we can perform 10 raised to the power 8 operations in time 1 second. So at max I can go up till n cube, because in n cube there will be 10 raised to power 6 operation and more, or let's we can say that n cube log n will also work. N cube log n, as it is 10 raised to the power 6 and log of 10 raised to the power 2 will also fit in this. Now let's see how we can do it with a brute force approach. For brute force we can iterate for a loop length is equals to 1 till length is equals to n. In that we can make another for loop. This is the first for loop, and for a length we can check if for a substring of j is equals to let's say from 0 to j is less than n and j plus plus. And for in this for loop we can check if for a given length of substring this, do there exist k ones, do there exist k ones. If yes, then store it in the answer string. Make a string variable and then store in it. Okay. Now in this the two for loops will make n square time, and for storing a string we know that big of n time is also needed. So at max in worst case it will take n cube time. So in brute force approach we can see that the time complexity at max be n cube, big of n cube. Okay. Now let's look at how to optimize this solution from big of n cube to big of n square log n something. How to optimize this? In this question they have been given that n we can be up till 100 only. So our brute force solution will be accepted on this platform. But what if they have been told that n is less than equals to 1000, or let's say they have told that n is less than equals to 3000 something? In that case our brute force solution of n cube will definitely give tle, time limit exceeded. So in that case our optimized approach big of n square log n will only work. So now let's see what is our optimized approach and what we are doing in that. So in optimized approach, we will think of binary search. Let's see how we can see a binary search. One thing is sure that if we have to take a substring of length L, yes. So if we have to minimize this substring of length L, so there exists a monotonic function in that. Means if for a length L, there exists a solution where ones are equals to k, so there will always be exist solution for L plus 1, L plus 2, L plus 3, and dot 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 dot, where ones can be greater than equals to k, greater than equals to k. And similarly, if length is less than 1, less than 2, here solution will always be false. As we can see that it is monotonic in nature, so we can apply a binary search on this. Now we know that for binary search we perform low equals to 1, low equals to k, because for uh, length to be at least k once, we have to be the minimum length to be k, and for maximum length we can go up till n. High can be our n. Let's learn a binary search loop or while loop. As we all know that in this, uh, let's we know that we are making a mid variable, and for this mid we are checking if there exists a solution or not, where 1 are greater than equals to k for this mid length substring, this mid length substring. Okay, so now let's look at a predicate function. What will be our predicate function? In predicate function we have mid variable. In this mid variable we have to make a substring of mid length, and we have to check that if there exist at least k ones or not. If there exist at least k ones, then the string str can be our answer. And if we have got this str, then for this same mid only we have to look lexicographically smallest also. So we have to continuously check for each mid length substring. Now if there exists a substring of let's say length equals to mid, where ones are always greater than equals to k, so it has been sure that the answer can be mid or less than mid. Means if substring is there, and if there are one dot 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 dot, some zeros and some one, so it is for sure that if ones are greater than equals to k, then in this substring only there exists another substring where the ones will always be equals to k, and the length can be less than or equals to mid. So when we are having this case where 1 is greater than equals to k, and for the given mid, so we can return true for our predicate function that yes, this can be solution or lesser than this solution exists. So we will keep an answer variable where we will add a mid in that, and we will update our high to mid minus 1, means check for more lower length answer. And if we have got answer in our predicate function, we will store in a global variable string in a global variable, because we have to, it will be easy for us to access it in our main function. That's why I have declared as global variable in this. And after doing a binary search, we will at last return our string. And one more thing in predicate function, if we are storing it in a string temp. In our predicate function, we are storing lexicographically smallest substring for a length mid in temp. And if our temp is null by performing this search, then we definitely know that this answer cannot exist. So we will not update our main global variable, else we will update our main global variable. So let's look at our final code of this binary search solution. We have initialized our global variable string, and here, then we have take our low as k, high as n, and answer as -1. Then we are applying a binary search where we are checking a predicate function. If predicate function returns true, it means the answer exists for this length, and we can go up to more smaller length. Else we have to see for better length, means more greater length, as there does not exist at least k once also. So let's look at predicate function. So in predicate function, we keep string temp is equals to null. Then we take int 1 is checking how many ones there exist. Then we can perform a normal search for a string, that take a mid-length substring, then check if there exist ones greater than equals to k. Means for I equals to 0 till I less than equals to mid minus 1, take all these things. Then after this, let's take from I is equals to mid minus 1 till I is less than n. And because for first substring it will be from 0 to mid minus 1 total mid elements, and we will add this in our one variable if there exists one. After adding, we will check if there exists one greater than equals to k. If there exists one greater than equals to k, and if it for first time, then we will assign this in our temp variable. Else, we will make a substring, and we will compare it with the current temp. If it is lexicographically smaller than the current temp, then we will assign it. At last, before going from this before moving forward, delete the last characters, means the character which will be at mid minus 1. Sorry, I minus mid plus 1. So we have to delete these characters, and if there is one, we have to delete it. Why we will delete? Let's see in two minutes. And at the end, we will check if the temp is equal to null only. So there does not exist a case, return false. Else maintain a string variable global, and in that assign a temp and return true. Now let's check what how we are seeing this logic, what we are doing in this. Let's check what we are doing in this logic. So if there is a string 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, so in this we are going firstly from 0th index till mid minus 2th index. Okay, in first loop, in this loop we are going from 0 to mid minus 2. Then we are coming on this index and checking this mid length substring, and checking how much one exists in here. After that, after checking this substring, we are moving forward to this index. In this index, we are checking this substring. To check this substring, we have to remove this element. So here we are removing this element in this, and then we are moving forward till the end of the string, and this length will be mid length. So we have seen that how we have optimized our time complexity from n cube to big O of n square log n. Now let's submit our code and check what happens. So it has been passed, and thank you so much.